So I got a little lazy when I made this video, and I actually just read the first part of the question. And I was like, okay, this is a mean value theorem question. This question is asking you just to estimate the number of points so that this is true, that the derivative at point C times B minus A. I don't know why the textbook is doing this. It's rewriting the mean value theorem. There must be a reason that I'm missing. But look, if you were to divide that B minus A from both sides, then you've got the mean value theorem. Okay? Because these are slopes. This is a y coordinate subtracted by a y coordinate over an x coordinate subtracted by an x coordinate. That's y2 minus y1 over x2 minus x1. So this is the mean value theorem because the mean value theorem says that if you evaluate the derivative, then there's some point C that you can match the slope of the endpoint. Okay. So let me graph this in Desmos and I'll show you what I mean there. What the mean value theorem means. Okay, so here's a graph of the function. We're evaluating the function on the endpoints -1 and +1. So here's where x is -1 is further down, looks like. X is -1 has a pretty steep slope, right? And then at x equals +1, if you imagine the slope at +1, it's also a pretty steep slope. Well, this is tough because it asks you to do it visually. It's really hard to find out the number of points so that you match the secant line slope. Look, between those 2 points, with our graphing utility, we have -1, -11. That's a point. And then at +1, what was our y coordinate? It's 15, I think. Yeah, +1, it's going to be 15. Sorry about the dogs. Okay, so if you find the slope between those two, I think you're going to get 26 over 2, which is 13. I mean, how can the human eye really spot a slope of 13? So I guess you probably want to watch along with the rest of the video because you can't really do this by graphing. You could estimate it, but how can you see that that slope of 13 is definitely going to come up again? So check out the rest of the video where I show you how to do this, not graphically, but using the mean value theorem and doing it algebraically. It asks you to first graph the function on a calculator and draw the secant line that connects the endpoints. So you could go to Desmos, you could graph this, and if they're saying a secant line, that means they want a straight line between the point where x equals -1 and x equals 1, because this is an interval. So graph it, find where x equals -1 on your graph, find where x equals +1, and then draw a straight line between those 2 points. That's the line that they're asking us to construct to answer this question. Okay. If you're graphing a secant line between 2 points, we're guaranteed that that the slope of that secant line exists somewhere on our function. That's what the mean value theorem tells us. If you have a graph of a function, my regular mouse died. I'm sorry, I'm drawing with my laptop's mouse. So let's say this is our function, and here's x equals -1. Let's make it a little different. Let's say this is x is +1. The secant line is the line between those 2 points like this. The mean value theorem says if it's a continuous function and if it's differentiable between those 2 points, then you're guaranteed to have at least one place where you'll have a parallel secant line, like this one, like it looks to be right around here. If you're to draw a secant line, it's parallel with that original line. This is basically the mean value theorem. I'm not sure what the textbook is trying to do by writing it like this. Look, if you just divide b minus a from both sides, then you get the derivative at some point c. That c might ring a bell to the mean value theorem. That's equal to f of b minus f of a probably easy for me to type, huh? All over b minus a. Just divide the b minus a from both sides. It's the mean value theorem because look, this is a slope. It's two y coordinates subtracted by each other over two x coordinates subtracted by each other. So what we need to do is we need to find the derivative of y with respect to x. I'll type it out here. There's our derivative. And then to find out what c is, we need to know what the slope is between -1 and +1. So we've got an x-coordinate of -1. The corresponding y-coordinate, if you were to plug -1 into this original equation, is -9 plus -4 makes -13. -13 plus 2 makes -11. So there's one y-coordinate. And then to find out the y-coordinate corresponds with x equals 1, we're plugging in 1 into the function. So we got 9 plus 4 is 13. 13 plus 2 is 15. And so the slope between those 2 points, you could do 15 minus -11, that makes 26. And then 1 minus -1 is 2. So that's 13. Slope is 13. And so what the mean value theorem says is that you're guaranteed to have 13 come up for a slope. In other words, 13 in for y prime at some point. So that's what we need to solve. When you solve for this, you're finding that point C that satisfies the mean value theorem. Okay, so if we subtract 4 from both sides, divide 9 from both sides, there's 2 places, x equals 1, and x equals -1. Those are the 2 places that have the same slope. So on this graph, at the endpoints, at -1 and at +1, we have the same slope as the secant line between those 2 points.